So let's continue. I hope you were able to fill up the table. Okay, so let's find values for x squared plus 1. So you substitute negative 3 to x, then you square it, then you add 1. Okay, so you're going to have all of this. 9 plus 1 is 10. Okay, all of that. You can see this in the transcript, and I hope you did it too. So what's the difference when I put the 1 inside the parentheses? So basically I'm adding 1 to x before I square. Here you square before you add. So you're going to get this, substitute negative 3 plus 1 is negative 2 squared, and we're going to get this. Okay, as you could see, there is a pattern here. So 10, 5, 2, 1, and then 2, 5, 10 again. So 2, 5, 10, 2, 5, 10. So this will be our lowest point, our vertex. Here there is also a pattern, 4, 1, 0, 1. Okay, so this one will be the same as the one here. 1, 4, then we will assume that this will be 9 for negative 4. Okay, so there's always that symmetry. So we're going to graph this, okay, both of this. So here I already made so we're going to graph the values of this, negative 3, 10, negative 2, 5. Okay, so I already had this table of, I graphed the parent graph, y equals x squared here on a bigger graphing paper, so we could see the changes later on. So remember, when you're graphing y equals x squared, okay, y equals x squared, this is y equals x squared, or f of x equals x squared. That's the parent graph. Just remember, you have to memorize the points: 0, 0, 1, 1, 2, 4, 3, 9. And then you just use symmetry on the other side. You actually don't need to count anymore. You know that that will be 1, that will be 4, and that will be 9. Okay, it will save you time because you have to graph a lot of this. So let's graph our green graph here. These values, negative 3, 10, negative 2, 5. Okay, so let's do that. So this is 1, 2, negative 3. Instead of 9, it will become 10. Negative 3, 10. So it will be here. Negative 2, 5. I'm following the table. Negative 1, 2. So you see there is a pattern. The points went higher. 0, 1 here. 1, 2, 2, 5, 3, 10. Okay, so here, as you could see, all the points went 1 unit higher. Okay, so let's join all of this. Let's just make a smooth curve. Let's join all the green points. You cannot make straight lines, okay, because this is supposed to be a function. Okay, so sometimes it's hard. You just get your own strategy. Okay, so you're going to do that. It's supposed to be a parabola. You cannot get a V or a U. Okay, so this one here, this I don't like because it sort of became straight line, which is not supposed to be. It's supposed to be curved. Okay, so let's curve that a little bit. Okay, like that. So this is the graph of y equals x squared plus 1. So I noticed that when we put plus 1, all the points went 1 unit higher. 1 from here, it went here. Oh no. Okay, that's why I made a mistake. This is supposed to be the vertex. When x is 0, y is 1. Okay, so it's supposed to be here. Like that. Okay, maybe you noticed that. Okay, so this is the graph of y equals x squared plus 1. Okay, we said everything went 1 unit higher. So let's get the summary for this. Let's describe this green graph. So this will be a parabola opening upwards, or the vertex is a minimum, the lowest point. Okay, why the vertex is at 0, 1, and it's the minimum point, lowest point. Minimum means lowest point, minimum point. And then we will get the line of symmetry, like the one we did here. We're doing the same. Okay, so line of symmetry, I'll just write LOS, is still the y-axis. Okay, still the y-axis. So y-axis, or x equals 0, the line x equals 0. X-intercept, there is no x-intercept because it did not hit our x-axis. Y-intercept is at the same as the vertex, 0, 1. Domain will be negative to positive infinity. Domain of parabola is always all real numbers, always. So range will change. This one will start with 1 to positive infinity. Okay, in the next video we'll graph the red graph.